Today we are solving LeetCode problem 206, reverse a linked list. Given the head of a singly linked list, reverse the list and return the reversed list. Examples are given for you. Let's understand how to reverse a singly linked list. So first of all, what do you mean by reverse? Suppose my linked list is 10, 20, 30 and 40. First node is 10, the last node is 40. After reversal, I want something like 40, 30, 20, 10, where 10 points to null and head points to 40. So we are not changing the data inside the node, we are changing the direction of the link. So this is the most important point to remember. To solve this problem, we are using 3 pointers, namely previous, current and next. Initially, previous is set to null because there is no node before the first node. Current points to the head, so it points to 10. Current is 10. Next will be used temporarily to remember the node that comes after current. So remember, previous is null initially, current is head, and head is now pointing to 10 in our example. Why do I need all these pointers? Because while traversing a link, we don't want to lose the remaining part of a linked list. So think of next as the backup pointer. So before changing a link, you first save where you have to go next. I'll be solving this problem in a 4-step logic. So let's understand the entire reversal algorithm with this 4-step logic. Step 1, simple, save the next node. Next is equal to current's next. Previous is null, current is 10. So next is equal to current's next. Save the node 20. Done. Step 2, reverse the link. Current's next is equal to previous. Now what happens? 10 is pointing to null. 10 points backward to null. So you have reversed the link. Done. Step 3, move previous forward. Previous is equal to current. Right. Step 4, move current forward. Current is equal to next. You are repeating these 4 steps again and again until current becomes null. Remember the 4 steps: save, reverse, move previous, move current. Repeat these 4 steps until current becomes null. If you remember these 4 steps, you can easily write the reverse linked list algorithm. Let's do a dry run. Iteration 1. Our list is 10, 20, 30 null. Initially, previous is equal to null and current is equal to 10. Step number 1, save. Execute next is equal to current's next. Since current is 10, next will point to 20. So you have previous to null, current is 10, next to 20. Reverse. Now comes the most important statement. Currents to next is equal to previous. Current is 10, previous is null. So 10 will now point to null. Earlier 10 was pointing to 20, now 10 is pointing to null. Step 3, move previous. Previous is equal to current. So previous moves from null to 10. Step 4, move current. Current is equal to next. Next was pointing to 20, so now current now moves to 20. So now situation becomes 10 pointing to null, 20 to 30, 30 pointing to null. The first link has been reversed. That's it. Iteration 2. Now current is pointing to 20 and previous is pointing to 10. Again follow the same 4 steps. Save. Next is equal to current's next. Okay. And then reverse. Reverse the link. Now after reversal, 20 is pointing to 10, 10 is pointing to null. Move pointers, previous forward and current forward. Done. Iteration 3. Again do the same step in iteration 3. So previous is pointing to 20, current is pointing to 30. Same 4 steps. Next is equal to current's next. Since 30 is the last node, next becomes null. Step 2, reverse. Current's next is equal to previous. So now 30 will point to 20. The list becomes 30 pointing to 20, 20 pointing to 10, 10 pointing to null. Third, move previous. Fourth, move current. Next is null, so current becomes null. So our entire list has been reversed now. 30 pointing to 20, pointing to 10, pointing to null. Fine, this is the exact position where we wanted. If we look from 30 towards null, the list is 30, 20, 10, null. Fine. Since current is equal to null, the loop stops. So look at the final result. our current pointer was null. Look carefully at what previous is pointing. Previous is pointing to 30. So therefore we have to make head point to previous. Head is equal to previous. So now the reverse linked list becomes head pointing to 30, 30 to 20, 20 to 10, 10 to null. So this is our reverse linked list. So because after reversal, the old last node becomes the new head. Fine. Look at the algorithm. To convert what we have did manually into an algorithm, initialize previous is equal to null, then current is equal to head. Repeat the 4 steps while current is not null. Number 1, save. Number 2, reverse. Number 3, move previous. Number 4, move current. And finally set head is equal to previous. Done, and you return the head. So the complete logic is very simple. Initialize, save, reverse, move, repeat, update head. Look at the C code. You declare the 3 pointers, then you use while loop. This means we continue processing nodes until current reaches the end. Look at the statement, next is equal to currents next. So this is the most important point. So you have to definitely understand the core logic here. So notice that the 4 statements inside the while loop are exactly the 4 steps we have learned earlier, is it not? Fine. So let's understand a very important question here. Why can't we simply reverse the link? Why do we need next? Suppose current is pointing to 20, 20 to 30 to 40 is my initial structure. If I directly change currents next is equal to previous, the 20 node will now point backward. But what will happen to 30 and 40? We will lose the connection. So that's why before changing the link, you first save. And next remembers where is the remaining list beginning, right? First save the future and then change the link. So that should be the motive. Fine. So talking about the time complexity is order of n because we are visiting every node at least once, right? What is the space complexity? We are not requiring any extra space. We are using only 3 pointers, so the space complexity is order of 1. So this is why the iterative approach is very fast, efficient for reversing a singly linked list. If you have any other logic, post it in the comment section. Thank you. Happy learning.